Alright guys, so seems that this little mini series was a hit. Got a lot of positive feedback about, making these videos and the last one that I made. And after I was like watching the videos, I started to take some notes of like things that I skipped over, things that I missed. And I'm gonna be jumping around a lot in this little series because honestly, you couldn't possibly organize this to answer all the questions, to give you all the knowledge about how to do this kind of stuff. So there's going to be a lot of jumping around, you know what I mean? So each video I'm going to I'm going to go back and watch myself and try to touch base on some of the things that was skipped over. Like, we talked about the ESC and, reading the logs and all that. But I didn't get into the settings for setting up for a speed run. So that's one thing I want to talk about today based off of motors and the settings that you need to apply in the ESC based off of like a Y wind motor versus a D wind motor. And I have I don't know if you can see it in the camera view, but I have an analyzer here with some motors on it and a motor broken down to show you the inner workings and the maintenance and things to look out for with your motors. So we're going to use the analyzer, we're going to do the tune on the ESC, we're going to go over the basics of an electronic motor. By no means am I like, an ace at this per se. You know what I mean? I'm only feeding you what I have learned and what helps me understand, this stuff the easiest way possible, I guess. I'm not a good teacher. I don't, you know what I mean? Like, this is just another dude talking about my experiences and how I do things, and I'm trying to break it down to give you guys a better understanding of how to do it as well. So, the motors, the ESCs, that's something I want to talk about today. Temp gun habits. This is something crucial to speed running. Temps, man, you gotta, electronics, heat kills electronics. So you gotta watch temperatures all the time. Speed running is not like, it's like drag racing. You're on real cars. They were meant to go from point A to B, not friggin' blast that, 1.3s and do all this crazy stuff we do in RC, So the same things apply for the RC car. It was never meant to do this. So all the things that we're doing to it is like borderline destroying them. So I just want to like give you guys, awareness to what you're actually paying attention to so that you can keep enjoying the hobby. A bug out bag for when you go out speed running. I'm going to show you what I take with me. I'm sure some of you probably already seen like a lot of my setup outside of, on the runway or the street, because I like to take a picture of it after I get set up, let everybody know I'm out there getting it in, and I'm going to actually go into depth in them boxes and show you what I carry with me and, some of the safety equipment and stuff like that. Stuff that you need, like realistically. These things light on fire a lot and they crash a lot, and sometimes there's just nothing you can do about it. It's going to happen, you know what I mean? So, these are some precautions to take and things to look out for and safety equipment that you should absolutely have with you while you're doing this. Let's see, what else do we got? I want to go into depth about power in a car, and when we're using it efficiently and when we're wasting it. Now, this is something that I have just learned myself, and I figured it out by experience. There was no way somebody could tell me this, you know, and I'm gonna try to explain it how it happened for me, so that, you know, you guys can start taking notice in that too. It would have helped a hell of a lot more, you know, in the beginning if I understood what was actually happening there, you know what I mean? So we're going to talk about power being wasted and power running efficiently. I want to talk about the launch control, the Perfect Pass. I use it on all my cars, and I'm going to explain why, you know. What else do we got here? I'm thinking about doing the range booster installed, because we went over, you know, the product basically, you know, just telling you what it was, even though I didn't even tell you what it was, because I don't even know what the hell the name of it is per se, you know. But hopefully the number on the box helped on like eBay or whatever the hell. And then we're going to talk about keeping slop in the car. People always try to remove as much slop as possible, and I'm going to tell you right now, it's actually needed. You know what I mean? Like, having that slop there is important, but removing it from the right places is what we're going to talk about. So that's what I got for this video. Bear with me, we're going to jump around a lot, because like I said, there's just so much to cover. There's no way I could cover all of this in one shot, or 2, 3, 4, and it would be ridiculously long. So we're just gonna jump around a lot, and on the next video I'll take more notes, and we'll go talking about other things that were missed. You know what I mean? Like, this whole journey is gonna build into a lot of knowledge, just coming from me and my experiences. Just things that I've learned and looked out for, and things, you know, steps that I take now, and all of it is definitely positive and as safely as possible, you know, because this is a kind of dangerous thing. So be mindful of that, have respect for it, because it is dangerous. You know, you got to imagine, you know, nobody wants to imagine this, but, you know, a 200-mile-an-hour friggin' 17-pound weight, you know, coming at your car or something, or, you know, some guy riding his bike down the street, you know what I mean? Just, we got to talk about that stuff, you know. So just be mindful of your surroundings and what you are really doing, and, you know, the worst that could happen. So we'll talk about all that, but that's what I got for right now. We're going to jump into this. I'm going to start now. All right, GoPro, stop recording. All right, guys, here it is, right? So we're going to talk about motors. I guess we could start with the I use 40-80 cans, 40-70 cans, 40-90 cans. I like TP motors for speed running. I use new motors. I've used Castle motors. I like TP. You know, this is just where I'm at with it. I'm going to talk about, you know, things that you need to address when you get a motor, right? So you go through the process of selecting a motor. You know, you go on the website, you figure out what voltage you want to run. You select a motor based on that, right? Okay, so we made it past that point. We finally got our motor, right? So the first thing that I do with my motors, now this is just a destroyed motor. I got a box full of them back there, and I want to tell you the things to look out for. So when you get a motor, right, it's going to come like this, you know, and it's going to have the end cap on it, right? So the first thing that we want to check is the shimming. So I want to push this motor, and this one is a demonstration motor. There's actually no shims in this at all. I don't even know if I could use this to test you. I mean, to test on the analyzer. I just don't care. But so you want to check this right here. You want to see just the teeniest bit of movement, right? You want that thing to be smooth operating, right? So that's the main thing to check when you get a brand new motor. Sometimes, a lot of the times, they come and they're just a little too tight. You know what I mean? So all you want to do is just give that a little teeny bit of play right there. I always look at the back of it, and I don't know if you could see this on camera. I'm trying to get it, but like just the littlest bit of movement there. That's what you want to see. About a millimeter might even be too much, to be honest with you, but it ain't gonna hurt it either. A millimeter is fine. So you want to have just that little bit of movement in there. It's not gonna hurt anything. It's actually gonna make the motor run, you know, pretty efficient. And when you get them, they already balance it in there. So that's what you'll see, these like little drill marks all over it, is they're trying to balance the rotor, you know. So you get your motor, you take it apart, you want to make sure that it's shimmed correctly, you know, that it's not in there too tight, because what that'll do is drive the amperage up on the analyzer. It'll make the motor run a little bit hotter. It'll stress it out. Remember how I talked about in the first video? Amps are stress in RC. That's it. You know what I mean? Just identify amps as stress. So you want to lower the amperage. You want to lower that stress, you know? And when you are running and you see all these marks on this motor, I actually sanded them off because I was out in the field and I was trying to get more runs out of the motor. But what happened here is that the motor got too hot and it started to expand, and what happened was it rubbed the inside of the can. Once your rotor starts to rub the inside of the can, it's damn near done for, you know what I mean? So I was out in the field and I had my sander and I filed it down just to try to get another run out of it. It was producing good numbers at that time, and that's what I did. So when you start to damage a motor, you're going to start seeing rub marks on the rotor. Time to go, man. Get it out of there. That's it, you know? If you damage the stator, you know, usually the heat alone that is making this swell is already killing the stator also. But if you happen to get like a bad rotor or something, you know, who knows? Any kind of circumstances can cause this to happen. You can swap the rotors. You can buy the rotor and put it in the can, and it's fine. As long as you didn't scrape the inside of the can out too much, or, you know, heat it up too much to where it took off the, it took off the heat resistance coating on the copper. It's pretty much good to go if you didn't destroy that or, you know, scratch the rotor all up. Once a rotor starts to rub, it's it, you know what I mean? It's just going to get worse from there, you know? So get it out of there, swap out your rotor, do what you got to do, right? So that's basically some things to look out for. You can also smell the motor. You know, if it smells burnt, it's done. You know what I mean? When you start getting a little bit of crunchiness in there, start paying attention, because that crunchiness is the insulation coming off of the wire itself. And it'll do that by, like I said, making it too hot. If your motor is 160 degrees on the outside, which, you know, like I said, you're always going to be checking these temps. Always, you know, every run you're going to check temperatures. If you're seeing 160 degrees on your motor, you're about 180 on the inner core on the rotor. So, you know, that's the end right there. You know what I mean? If you start going over that, it's a matter of time before you're going to kill the motor, you know. So a healthy operating range, I don't know why the video cut, but a healthy operating range would be from, you know, 90 to 130. That's the temperatures you would like to see your motors at all times. Once you start getting like hotter and hotter, you should be doing some really big numbers at that point, you know, because you're putting a good amount of strain on the motor itself. So, you know, that's some things to look out for. How to shim it, you know. Sometimes you got to add a shim, sometimes you got to take away a shim. You know, 9 times out of 10, you're going to end up taking out a shim. Yeah, so you want to, you know, make sure there's a little space in there for the rotor to do its job. And oil the bearings that comes with it, and just general maintenance. Don't expect a motor to be perfect out the box, even though it should be. They're producing a lot of these things. It's hard to keep up with, I'm sure, as a business, to make sure every motor's perfect. Listen, I know they try, but you can't. Sometimes a bad one gets slipped through. You just got to check them yourself, really. So we got the motor. We shimmed it. We made sure everything was good there. Everything was oiled right. Now we get over to the analyzer. This is I think this is a Sky RC, or no, this is a Power Hobby one. But Power Hobby, Sky RC, they all, they make these motor analyzers. And, you could check your KV, which we'll get into here in a second. Hold on a second. Motor timing, that's also the next thing we'll get into. The noise level and pole and motors. So, 4080 cans are 4-pole motors. So we're going to start with just setting that to 4-pole, just so, everything we talk about, we can simulate and be on point. So that's the first thing you want to do when you get your analyzer. You get your motor, you're going to put it on whatever pole it is. If it's a 6-pole, 4-pole, 2-pole, whatever. So we're on 4-pole, right? So I got my new motor. Let's say, I don't even know. Let me see. Let me run this real quick just to... I don't even know what this motor is because I swap rotors and stators around, which changes everything a lot, So, looks like this is at 1940. So, I don't know if you can see that data on there. 3.3 amps, which is really good. You want to be under like 6-7 amps. And, that's good. 3.3 is really nice. It's running smooth. It's not under any stress, really, at all. So this KV is saying 1940. Let's see, what's the can say? 1950. So it's actually close. It's actually really close. The RPM is 14,748. But this is the thing, right? So this is a DY motor, and then there's a YY motor. All motors... Hold on, let me step this back. I'm sorry. Let's talk about the KV. KV is going to be within 10% from most manufacturers, is going to be 10% to whatever it is. So this is 1950. I'm getting 1940. That's awesome. You know what I mean? So it's really close to its true KV. And when you're like gearing a motor, you have to go off of the true KV. Dude, that KV can be off by 150 KV sometimes. You know what I mean? Like, you have to check the motors. You may think you have a 2000 KV motor, and it end up being a 1900 or a 2100 KV. You don't know. You have to check it on the analyzer. So I'm running this on a 2S pack. This is what the analyzer is meant to do, 2S. The manufacturers do it, well, TP does it on 3S. You know what I mean? At 10 volts or whatever. So we want to find out our true KV. Now we got it, right? So now we can gear accordingly to our true KV, right? The RPM, yeah, it tells you something, you know what I mean? But it's just giving you its RPM. It's not really useful at this time. So this motor is a DY motor. Deltas require 0 timing. You can add timing, you can play with that, but you have to check on the heat. You gotta stay on top of temping that motor and make sure that the timing's not actually drawing a lot more heat. You know what I mean? And you're gonna know, you know what I mean? The timing changes the temperature a good bit. You're gonna know that, when you see it. So this is a D-wind. A Y-wind You can test on here if it's censored, and it will actually give you the timing. It'll tell you what timing you need to apply on the ESC. So we're going over all this to actually step into the ESC tune. But first we have to identify the motor and what it's doing and what kind of motor and all that good stuff. We need that data to go to the next step. You know what I mean? So an analyzer is something that you're going to want to get. You should absolutely have. And start checking your motors and write it down. I have a whole book full of information on the motors, so I know what I have, and I select the gearing and speed and everything else, and I write all that data down. So I keep that in the future. So any other KVs, you want to compile as much data as possible. I can literally pick up any motor and pretty much put it at 180, 190 miles an hour first try, probably. Not 190 first try, but definitely in three tries I will have that motor at 190 mile an hour, based off of all the different KVs and different motors that I've used. So keep data, keep all that information in there, keep it to yourself and use it. You know what I'm saying? So, all right, we identified the true KV. We seen the amperage. This is a very healthy motor at 3.3. That's actually, probably because it's not shimmed at all. There's like no resistance at all. We know it's a delta, so we don't have to worry about the timing. A Y wind, we would start adding timing to it and checking with temperature. Check with temp gun after you run it. If the temps are, how can I say this? Let's say you're running at 120 degrees and you add 10 degrees of timing or whatever. You shouldn't really add that much that fast, but let's just say you start walking the timing up and you see that the temperature's going up, and then like, all right, let me back the timing down or go higher, see if it got hotter. It's a playing game. I can't give you the information on that because I don't necessarily know myself. I play with it, you know what I mean? And once I see the temperatures drop, then I know, I'm like, okay, that's where the motor wants to be at. That's where it's not running hot at. So that's Y wind's a whole different thing. Actually, yeah. All right, we'll talk about that stuff later. But so we know what we got here, right? So now we can step over to the ESC, right? Let me see. Let me check the view. All right. So we're all plugged in, right? We got our Castle Link on there. So now we're going into the ESC, right? So first thing I want to do is I want to go to basic, right? Cutoff voltage. I want no cutoff. It comes with auto LiPo cutoff. So if you're speed running, you have to turn that off, dude. You want that thing to, to just take whatever you're throwing at it. You know what I mean? All this other stuff, it doesn't really apply too much for the speed run part of it. Your BEC voltage, if you got a good servo, good receiver, and all that stuff, you can increase it. I use, my receivers are capable of 7.5. But I only put them up to 7. That's just basically giving the servo a good amount of power, giving my gyro a little bit of power. You know what I mean? It's just giving it a little bit more to work with there. So my brake amount, that's in the neutral position at 50%. Sorry, I'm trying to hold this better. Every motor is different. Even the same exact motor that you buy per model, say I got two 2400s, they will have different brakes on them. I don't understand why, but they are different, you know what I mean? Sometimes they're dead spot on with each other. Sometimes they ain't, I personally think no motor is the same. Even the same model, series, all that good stuff, they vary. These are handmade, I think, so the amount of copper that goes into each one, or windings or whatever, it's not an exact science, but it's pretty close. That's why they give that 10% fluctuation between data between the motors, you know. So break them out. I'm going to start at 50. I'm going to get out in the field and I'm going to feel it. If it feels good and it's stopping the car, then cool. If not, I'll increase it. If I feel it's stopping too much, braking traction, all that good stuff, and I'll back it down. You know what I mean? It all depends on the distance that you have, the speed you're hitting, all that. That's something that has to be figured out in the field based off of how fast you're going and how much space you got, you know. So I leave that in the neutral position until I figure out, you know, that setup. You know what I mean? So start power, always on low. There, you don't need to put it on high. I don't know why people do that. It's I don't know. I don't get it. It's not necessary. Just put it on low. You want the ESC to behave as healthy as possible. Max power is 100%. Reverse percentage. I put mine to 20% on all my cars. I do not want to have my car 2,000 feet out there where I can barely see it and I'm trying to turn it around and it hammers in reverse. No. And then it goes off the street or, you know, gets stuck in a ditch or off the side of a runway or something. And then you got to go all the way down there and get it while you're, you know, you're losing battery and all that good stuff. So I put my reverse percentage at 20%. So when I hit it, it creeps back slowly, and I do a nice couple point turn and get straight again and do my run. So that's something you want to keep low because out there in the distance, it's hard to judge turning it around, and you don't want it launching. So go into advanced. Actually, you know what? Hold on, let me see. Okay, punch control 0. Okay, I'm looking for something specific here. Okay, so here's your motor direction. You can either swap your wires around the A and C on the motor, or you can come into the ESC and change the direction. I just changed the direction in the ESC so that my wires are not crisscrossed and all that crazy stuff. Now we have the motor timing right here. Since I have a D-wind, it wants to be at 0. Deltas all want to be at 0. They don't want no timing. You know what I mean? Only time you're going to mess with that timing is when you're using a Y-wind, and you're going to have to constantly change it and check the temperature every run and find that sweet spot. That's the only time. So identify if your motor's a D-wind or a Y-wind, and then you can deal with that. And like I said, D-wind, nothing at all, 0. You know what I mean? So we'll go over to logging, right? Auxiliary wire, I cut out. I don't even use it. BEC voltage, doesn't even matter. Motor temperature, I don't have any kind of like sensor on it, so it's just irrelevant. So turn these things off because it will give you more time to save data. You know what I mean? It's less things that it has to look for and it has to log, is the less processes it has to handle. You got to understand, it's like a computer. If you're running a bunch of programs on your laptop, it's going to be hotter. It's going to stress it out. It's going to make it harder to operate. So if you ain't using it, turn it off. You don't even need it. You know, you're not paying it. You don't care for it. Turn it off. You know, it's going to make the ESC run smoother. Your sample rate, you know. Now, these things, I turn them up to 10 because I want to see as much detail as I can in my log. That's what that's going to do. It's going to change the amount of detail that it's checking for. I mean, it's going to change the amount of times it's checking for the data during a run. It's doing it so fast. So I want to do 10 samples a second because I want to get as much data as I possibly can. You know what I mean? So I'll set it to all that, right? So basically you guys can see all the things. The rest of it, throttle curve, sometimes I'm using it, sometimes I'm not. You can do it on here or you can do it on your remote, either or. But it's not, you know, you don't really need it at all. Well, listen, I'm gonna keep it real with you. I hit 220s and shit's linear as hell. So brake curve, I never mess with that. I couldn't even begin to explain that. I don't even understand the point of a brake curve, but whatever. You know, maybe maybe it's used for the other bashing and stuff like that. But speed running, nah, you ain't even got to bother with it. Save, print, all that good stuff, that's all normal. You're logging, right? So we'll just hit update, bam, and that's where we'll set everything. I already got this one done, so I'm not going to mess with it. But that's the tune. That's what you're doing for speed running. There's no crazy changing all this. It's super basic, It's all you need. Speed running's so simple on the ESC side of it, you know what I'm saying? All right, so that was the couple things we went over. So we got the Castle tune out the way. No motor's the same. On the analyzer, talked about that. Temp gun habits. Yeah, I mean, you're always going to check your ESC, and you're always going to check your motor. Those are the two things that you're going to be constantly wanting to temp. Now, the ESC, it's going to show you that data on the log, but the motor, it won't unless you have some kind of sensor on there. But always check it, you know what I mean? You want to be at those lower temperatures. Keeping slop in the car. All right, so here's something that I wanted to talk to you guys about. I'm going to take a quick break, and we're going to jump back into this. All right, GoPro, stop recording. All right, guys, now we're going to talk about slop in a car. That calls for your axles, drive shafts, pretty much anything that, has some movement in it, right? So I build my cars. I used to do everything like, I got to shim everything so perfect and blah, blah, blah. Dude, I'll tell you what, man, it did nothing but destroy my cars and make me have more maintenance on them. So realistically, guys, let me see, I'm going to have to hold this camera and see if I can get it up in here and show you. You see how much movement is in there? This is the kind of movement you want. I can't get to that one, but it's moving like this. You want your drive shafts to have that play in it. Same with the axles. You see how there's play in it? My finger's sliding across a bit. Really, there's that much movement. You want there to be movement within these shafts, right? So let's see. There, I got the camera right. All right. So if they're too tight, dude, it's gonna put super amount of stress on these things, right? The cups are really good as long as you're not like on the very edge of the cup. You're probably not gonna break it. If you have too much there, you can put one of those little O-rings in there and to like even it out. So what I'm saying is, if the pin is favoring one side of the cup, then you would like to put one in there just to split the difference and have that little bit of movement. If you don't, if you do put too much in there, it'll actually bind and snap or bend the shafts. So you got to think, man, when this thing is just spinning, right? It's spinning. You want this to float. It finds the position it wants to be in, and it just rocks out, Vibrations are a killer for drive shafts, bearings, and bearing housings. So you want to eliminate that vibration. Now, if you have things binding up, all you're doing is like you're putting stress on the joint, and that joint is going to try to transfer it to the next one, and so on and so on. But what it's doing is it's going through each bearing and wrecking out each bearing, and then creating all that vibration. That vibration is going to make you lose mile per hour 100%. It's going to cause damage to the bearing housings and the bearings. Buy yourself a nice bearing. I use these Too Cool Customs. They're the Diaz bearings, and I like his bearings and springs on my dual motor cars. And on the singles, I use Raz's springs. I like that for my single motor cars. But these bearings are a hybrid bearing. Apex 7, super smooth, dude. They really do, man. You could whip them things and they just keep on going, right? So I buy like a thermal oil for them so that it keeps heat down with inside of them. These are ceramic bearings, but it's a hybrid, so it's got like the steel case and ceramic bearing. It's like riding on glass when you're using ceramic bearings. Now, I had in the beginning, I went and bought a full set of like sick ass Boca bearings, man. And I'm telling you, that car was so smooth. But, I will tell you, it is like riding on glass. I got in one accident with the car and it was over, man. A lot of the bearings were damaged, and it was like hundreds of dollars worth of damage in bearings alone. So you don't need that, man. Get a hybrid bearing, a decent hybrid bearing, and you're probably pretty good to go. Everybody's got their choice of bearings. I like those. I put them in all my cars. They work great for me. They really do. Make sure you oil them up. They come dry, and they spin super fast dry. So don't get it confused. You have to get oil in them. They are dry. So put the oil in them and load them in your car, and you shouldn't have any issues for a long time. I use thermal oil, like I said, to keep the heat down, the temperature, and all that good stuff. But like I said, you want to have that slop in the cars, and you don't want to transfer all that vibration through the car, because it will destroy the bearings, it will destroy the housings. Where you want to tighten up on slop at is in the steering. That's it, really. Everything else, you want it to freely be able to move. But the steering, you gotta have just right, if you ask me. You know, you don't want to have it too tight, because what happens is you'll go to correct during the run, and the servo is trying to return back. But since it's so tight that you have it so, all that slop taken out of it, it gets stuck like that. So you'll correct, but you'll point in the direction you corrected to, instead of correcting, returning, and going back to straight. You know what I'm saying? So I use the Servo Saver Delete. The VTE2 comes with like a 20-pound spring, and it's just not enough when you got 50 pounds of downforce. You got the weight of the car and everything else, and it's doing 180 plus miles an hour. That Servo Saver spring is killing you. You're trying to turn and the car's not turning. That's why. So get rid of those springs, because they're not built for this. They were never meant for that, and they can't handle the job. Servo Saver Delete is absolutely crucial in a speedrun car. You need that. You gotta have it, because like I said, you don't want to be going too fast and unable to correct, and then when you do, car's not turning and it's going straight into somebody's personal belongings, or car, or in the road, or in grass, crashing, whatever. So do your steering right, take the slop out of that, and don't over tighten this. If you over tighten these, like I said, it won't be able to return right. So you want it to be just smooth, have a teeniest bit of slop in it. Now when it comes to like the hubs and stuff like that, you can shim that stuff out if your wheels are like wobbling a little bit. On the VT2s, I put the shim on the inside of the rear. So if you put it on the outside, it wants to like pinch the hub, and then it starts to bind too. So it's hard to see, but these are like loose. You can move them. You got play in them. You want to have that play. All that. When the car gets going and it gets going up to speed, and it's freely moving where it wants to, with the downforce of the wind, it's going to stabilize all this stuff. So don't think that it's like too loose, because it's not. When it gets going and it gets speed up, like a street bike, it wants to stand up. You know what I mean? So the faster you go, the straighter it wants to go. Have that concept in the car as well. Understand that things have to be able to freely move. Don't make things too tight. It's really going to hurt you, and you're not going to understand why the car's pulling, or this, that, and the third. So have that slop in there, but make sure there's none in the Servo Saver Delete. Everything else, you want a little bit of play in it, and it took me a while to understand that, and it took a lot of trial and error to understand that. You would think it's something simple, and that you would you know, it wouldn't be an issue. But at them speeds, you know, you're doing 180, 190, 200 miles an hour. The slightest bit of turn is drastic in the direction that it wants to jump to, or you know. So we'll get into in like the next video talking about like the remote setup and how you want to set your steering for a speed run car on, you know, on your road. Now some guys don't have that like super flat, or they got like a bumpy surface, or you know, so you have to adjust to any road situation. You can't just set a car up and expect it to be perfect everywhere you take it, because it's not going to work like that. You got, you know, the ruts from tire tracks on the road, so some roads are crowned real good to have the water come off. You have to pick a side of the road and tune the car to ride on a bank, pretty much. You got, you know what I mean? Like, these are so little that bank is a big difference. It's like, you know, running a real car on a racetrack with a bank. You know, you got to set it up to run on the bank. So, you know, be mindful of the crowns in your road. Pick a side of the road to stay on, and set your car up as if you're doing the pull on that road in that direction. You don't want to set it up to go, you know, you don't want to try to set your steering on the way back, like going to the starting line. You want to go to the starting line and set your car up as if it was doing the run. You know what I mean? On that side of the road, you know, all that. You want to try to simulate the same thing as if you were going to do the run, you know. Little things like that people overlook, and they find a big struggle in getting the car set up right, you know, because they're trying to do it with different environments and different things, and it's just makes it way harder. So always set the car up like you're doing the run, you know what I mean? Don't worry about how it's acting going down there. Just know when you turn that car around and you go to blast off, it's going straight, you know what I mean? So just focus on that pull. So keep that slop in the car. Don't bind up the steering, you know, don't bind up any shafts anywhere. And if you feel it's too much, you can add one little O-ring in there just to you know, tighten it up a little bit. But you always want that movement in them. You know, don't overlook that. It'll really screw you up. So that pretty much goes for all the slop in a car. It's actually needed. You want it to be there. I guess real quick we can go over the slop in the gearing. You know, if you can hear this, that's how much movement you want between your teeth. Some people stick a piece of paper in it and mesh it that way. That works in the beginning, you know, but like for a dual motor car, I wouldn't do that. I would really try to get it set right. And when you are setting the mesh, you want to set it to where the pole is not putting force on the spur. What I mean by that is the resistance in the motor. Make sure that it's in a neutral position when you're trying to do the mesh. You know what I mean? Don't have it half cocked and try to be doing it that way. It's on a dual. You could do that on a single, whatever. It's only one gear, one connection between the spur and the motor. But on a dual, make sure they're in the neutral position before sticking them together. All right, so yeah, that goes over that. We'll move on to the next thing. GoPro, stop recording. All right, guys, so I want to talk about the field stuff, taking what you need to do the speed runs. I'm actually going out tomorrow. This video was shot in on New Year's Eve, actually, so it's very recent. I don't know if I'll get to posting this today, tomorrow, whatever, you know, I don't know, got a lot going on today. But I'm actually going out speed running tomorrow, and I thought my season was over and I had everything put into hibernation. So for the past 2 days I've been, you know, getting everything worked out, getting things together, picking up on cars where I left off at, and just getting prepared to go out again in, you know, this is something that we do in spring. But I'm gonna bring 3 singles out with me. I'm not gonna bring the duals with me. The temperature is just too low. It's too dangerous with the wheels being brittle because of the cold weather. We got lucky and we have some warm days here, about 50 degrees. So I'm going to take advantage of it with flying restrictions being in place tomorrow. It's the opportunity for me to go out and get some runs in the middle of the winter. So I'm going to do it. So this is what I'm taking out with me tomorrow, and it's a perfect time to kind of go over, some of the stuff that you need to bring out with you, or that you would, want to bring out with you if you plan on sticking it out the day and really putting the work in. So I'm just going to go over what I take with me. Everybody's bug out kit's a little bit different. This is what I take out with me. And I want to tell you guys right now, I'm going to start with the safety stuff. The most important thing you can bring with you is a fire extinguisher, dude. I get these by the 2-pack at Home Depot, man. Seriously, get them. Dude, there's been incidences where it hasn't rained in a month and it was really dry out, and I've had some crashes where, packs light on fire. And dude, if I didn't have a fire extinguisher, holy crap, dude, the amount of damage or anything, it's endless of the destruction that could actually happen. So please, guys, dude, we do not want to be on the news for burning half of a friggin' forest down, or somebody getting hurt or property damage. We want to run these things, and we want to be left alone while we're running them. So guys, take the safety, bring a fire extinguisher. Please bring it. You're doing us all a favor by doing that. So, number one thing, Now, James has actually talked about putting batteries on your receivers. Dude, it's a great thing. It really is. I don't really blow ESCs anymore as much, so it's very rarely that I will actually lose control of the car, or something happen where I lose signal or something like that. It's like a pretty clear area. There's not a lot of electrical interference or anything like that. So I don't necessarily put them on all my cars, but you should. You know what I mean? 100% you should. If I were to say, like, put it in order, dude, fire extinguisher first, batteries for the receiver second. You know what I'm saying? Like, them 2 things right there can make a huge difference. So if you guys got the extra batteries, dude, please put them on your car. Where I run it, I don't necessarily need it, and where I'm at with it, I don't blow ESCs to where I don't have control of the car anymore. But listen, dude, stuff happens, and it doesn't matter if the ESC is brand new. Something could fail, and that'd be it. I've been lucky, fortunately. Some of my cars, most of the duals absolutely have. Most of them do. You know what I'm saying? Like, I absolutely run them on there anymore, because those are pushing, the limits of everything and hitting ridiculous amount of speeds. And if you do lose an ESC, you still can control the car and scrub off speed. James talked about it. Other drivers have talked about it. But that's not what we're going to talk about right now. We're going to talk about the bug out kit. You know what I'm saying? What you want to bring with you if you're going to go out for the day and go speed running. So we already, covered the speed run stuff. I'm bringing out 3 singles. Normally, what I do is set a set of packs per car. So each car has its designated set of packs. This is just how I regulate my data and keep things consistent. I keep everything with that car. That's why I have so many cars, because I leave them alone. You know what I mean? Small changes and everything's documented, and that's how I've had such gains so fast. It's doing the work. There's a lot of work involved in this stuff, and to be meticulous will benefit you tremendously. So I'm going to take out 3 singles tomorrow, I'm sorry. This one is like a test battery car with a test motor. That is a complete unknown. I'm going to play with that tomorrow. But these two cars, single motor, I'm trying to break records with, and they are some bad boys right there. So they have backup motors with them. I keep, let me see if I can get this open with one hand. I keep backup ESCs with me to swap everything. We'll get into that. Swap everything and anything in the field. I come prepared. I'm here to break some records. You know what I'm saying? So I have pretty much a full car or two in that box. So if anything fails, I can just swap it out. You know what I mean? And if for some reason I don't have it, I'll snatch it off another car. You know, I take multiple cars with me. I try not to do that, but there's some circumstances where I had to before, and you know, it is what it is. Take them home, fix it up. But yeah, these two are coming out, and they're gonna put in some serious work, as they always do, and got replacement motors with them, test packs with them. Those are the SMC V4s. They're still in testing right now. So far, whoa, gonna be a fun year next year. You know what I mean? 25 is definitely gonna be some bombs dropped there for sure. All right, so I got my remote. You know, this is Futaba 10PX, and it's got a range booster on it. I just knocked the battery off. Yeah, it's just a 10PX with a booster. It's a little dusty right now. I got to clean everything off. A little battery with it, you know what I'm saying? In my box, always keep the temp gun. Man, you need to check temps constantly. Bring your temp gun. Extra batteries for the remote. Extra batteries for the range booster. Clips. My Castle Links. I bring all that with me because oh yeah, I forgot. The laptop, yeah. You got to bring your laptop with you too. Don't forget that. You know, if you're not looking at your data and correcting it right then and there, what are you doing? You know what I mean? Unless you just want to go out for the day, get a couple runs in, and come home and diagnose and figure things out there. But I like to bring all that stuff with me because when I'm in it, I'm in it. You know, I'm setting. I'm trying to have it at peak performance at all times, right? I got my GPSs. They're actually charging right now, but I'll put them on this, and then I swap them from car to car this way. It's what works for me. It's pretty easy, and I just go from car to car to car to car to car, and you know, whatever. You keep extra ones with you. I got a bunch of stuff like charging right now and taking care of all that. Get yourself an MIP bag. You want to have your tools all on site. This is one of those race boxes, the micros. You know, I think it's a pain in the neck to use. Hopefully they come out with a better update for it. But it is what it is. I'm going to bring it with me just for sake of extra detail. I don't really. The speed difference between them is almost identical. If this one gives you a little bit more in depth, but they're pretty much identical. You know, they're on the same mile per hour is what I'm trying to say, and this one just gives you that little bit more within the mile per hour. So, you know, you got your kit, you got some extensions for some batteries and whatnot that don't make don't reach to wherever. I might add an extension on some of the single motor cars. I don't like to. I try to keep everything connected with as minimal joints as possible, as we talked about before, but sometimes you need it, you know. You got all your MIP tools, pins, all that good stuff, an extra Castle Link in there. This is a little messy because I was rooting through it earlier. Yeah, I mean, just your basic tools, you know. We don't got to talk about that. You guys know to bring tools with you. Simple as that. You can get these MIP bags. You can build a kit. It's pretty cool, you know. It keeps everything together, organized, and, you know, you got it all there. I bring out a box of hardware. You're always losing a screw or something, or, you know. So it's always good to have your hardware with you. I just keep in a little bin right there and throw it all in there and grab what I need when I need it. me put this up real quick. And we're gonna like talk about setting your remote to your car and tuning the car from the remote on like steering and dual rates and all that stuff, but it's just not in this video. You know, we're gonna make a series here, and we're gonna talk about a bunch of stuff. Gears, dude, you need them, as many as you can get. I got a ton of them. Constantly switching gearing, constantly. You know, you're finding out what's working, and if you've got a bunch of different motors and all, you need that gearing. So get yourself a bunch of gears. Saga, Savora, best gears in the game by far, for years, been used. I just tried some of David's Scorch gears. Awesome too, man. Really, really good quality, sharp. They look good, man. I'm testing them right now. I'm gonna run them on a car for the first time. I put them on a car. Didn't have any wobbles on them. One did, and David replaced it. No problem. You know what I mean? It was, get one slips through here and there. I talked to, Savora about the whole gear things too, like in the past, and he has to check every gear. They all do, any company really. They got to check them, you know. But I use Saga gears. I swear by Saga gears. I really don't like to use anything else. This is he's been doing this for a very long time. His gears are used in every fast car ever. You know, it's just Saga gears, man. It's just where it's at. I think it always will be, probably too. You know, he's made such a good name and such a solid gear, you know. So get your gears, you know, obviously, you know, you want to keep the normal stuff. I threw a bunch of bullets in there too, because, you know, you're always doing a quick solder while you're out there. You get yourself a little portable solder gun. You know, they suck. They really do. There's nothing like the benchtop ones. But when you're in a pinch and you gotta, you know, solder a bullet onto a motor or something, man, you know, that cooked off or whatever, you just, it's good to have that stuff, man. The rest of it in this box, let me see. I don't know if this thing's gonna tip over. It's got a lot of gear weight in there. I keep extra ESCs with me. Tires, man. Oh, I don't even want to get into that, dude. Tires are the death of me. I probably spent about $6,000 last season on tires alone. That's because of duals. They're just ridiculously fast, ridiculously heavy, and we're running on a foam wheel. You know, they are going to blow. Just when are they going to blow is the key. And how you can prevent them from blowing faster, you know what I'm saying? So that's a topic for another discussion. Carry a lot of tires. Sometimes I'll usually bring probably 12 to 15 runs worth of tires. So do the math on that, man. You know, talking about fucking over $1,000 a day in running. You know, it's up there, dude. If you want to run them duals, which these are all duals on the wall. These are the only singles here. So, you know, yeah. And I'm telling you, man, it's expensive. So, you know, do it right and make sure it's worth it, man. It's about $100 a run. So, you know, tires are tires, right? So you got your ESCs, you got your tires. Another ESC. Like, I program and set these all up. This one's actually for a dual. It's the reverse side of a dual, if, you know, because of the ripple killers on top. So that's the only reason why they're in there. Those are actually built for singles. This one's a replacement for a dual right side. So got to have one of them in there versus, you know, having a left and a right, based off of the way I build, you know. Extra rotors, like I was saying, you guys, sometimes you cook the rotors. You want to have some rotors to swap in and out. Crashing, you know, you crash, you got to have your arms. I keep metal arms, front, back, rear, plastic. Basically, whatever that car has on it. Receivers, keep a receiver. I keep an extra gyro. Any another servo, any kind of electronic component, I try to keep at least one of, you know. Sometimes I keep more, like the ESCs, you know, shocks, straps. I'm constantly breaking straps. But here's the thing, I don't break the strap, I break the link. You know what I mean? So Vora, if you could do something about these links, that'd be awesome. But other than that, strap has never broken. Super good Kevlar straps. Awesome for the dude. Best investment I've ever made. I went from, you know, ejecting batteries constantly. I don't know if you guys seen the video that made it on ridiculousness of a car crashing at 190 mile an hour. Got like 63 million views. It was nuts. Made it on the ridiculousness. It was kind of funny. I got it on my Facebook page if you guys want to check it out. I think it's episode, hold on, season 43, episode 22 or something. I don't know. It's got a whole category of, like, I think it's called Radio Control Chaos. And it's pretty funny, man. Them guys are all right. They're pretty funny. So you keep all those components. This is like the mechanical side. I don't know if you can see it in there. This is like the mechanical side of it. You know, you want to keep your cups. I keep a locker in here. I run lockers on almost all my cars. I haven't started running diffs until this year. I only got 3 cars with diffs in them. One's a drag car, so it's different. But 2 speed run cars with diffs in it. It's not something that I run. I like locked, you know. I feel like it's one less thing that I have to worry about. I like the power to be equally distributed to the wheels. For me, it works. I'm trying to figure out right now if tire damage is more or less using lockers or diffs. That's something that I'm working on right now. Hopefully I can help you guys out with that by the end of next season, because, you know, when we're testing stuff, dude, nothing is a guarantee until you do it over and over and over again. You know what I mean? So anything that I do or I'm talking about, I'm pretty positive on, based off of constant, you know, tests. You know what I'm saying? I don't just do something once and be like, okay, this is what it is now, because it doesn't work like that in this. There's just way too many variables. You know what I mean? So hexes in here, some of these M2C ones, got a bunch of those in here. I like them. They're pretty cool. They were definitely needed on the quad cars. Duals, you know, you could put them on there, but I never really stripped out wheels. Sometimes you do it on some hard braking. If you're really trying to stop fast, you might strip out some hexes. So if you want to use these, they're good. They have the low profile ones, and then the ones that stick out. Notice I got both of them. I think, yeah, this car has the low profile ones on there. That one, I had put it on there because of the way I had my body on that car. So that one was good. That's what I needed to put them on there for, because I use these dual lockers right here for your wheels. This is a little tip or something we could talk about right here. This is a dual lock. So what you do is you take the grub screw out of the universal, and you put the tire on, and you put the hex on like normal with a cap, but it's got a hole here, right? Well, they come with these big, thick screws, and then you put the screw in, and it locks the pin, hex, cap, everything, all in one shot, and they do not come off. They do not come off. You will never lose a wheel. I have not stripped one due to this or anything, but they stick out a little bit, you know what I mean? So you can't run your body straight down the wheel, you know, like you can with the low profile ones. So I run those. They're on every single car, you know what I mean? Every one of them's got it. There's like certain things that I do with my cars, and I stand on it, you know what I mean? Every car will have them, certain things, you know? So I like them. They work. The M2C ones are awesome if you want to bring your body down past the wheel. Perfect for that, you know? If you're running a super aggressive car and you're stripping out wheels, get them. They work. They definitely work. yeah, it's just, you know, parts or whatever. But I'll tell you what, I got every single part that I use, hop up and OEM, in this box for, you know, whatever may happen. You know, you've been hubs and stuff or whatever, you know. Universals in here, everything's always new. These ones are actually used, but extra bones for the through shafts, all that kind of stuff, bearings, more caps, these pin holders. These are different. They actually came out with new pin holders. So some of my cars still have old ones, and then some have these new ones. These are awesome, man. They work really good. I try to keep every hopped up part that I use on my wall and in my box. So I got pretty much 2 of everything at all times. So when I'm out there, it's game time. You know what I mean? I ain't turning around. I ain't going home. I ain't not doing nothing because I don't have something. That ain't happening. That's part of the dedication and how I got here and how I got so fast is that I take preparation seriously. So if you want to get out there and you want to put that work in, dude, be prepared. Seriously, it's going to make a world of difference. It's a little cold out now. Like I said, it's winter. So I have these tire warmers here. I'm going to keep my tires warm. The ground's really cold. You don't want the wheels to get brittle and break, crack, whatever, fracture. So I will keep my tires a little bit warmer because of the cold weather. And yeah, that pretty much sums out my bug out kit. Another thing that is not in here is my chargers. Currently charging packs right now. Actually, I gotta swap these. These are all done. I'll take a charger with me, and I'll have this pack here. This will come with me, and what's in here is a long line. A little messy because I haven't got to this yet. Well, this is to hook up to your car battery so you can run your chargers and charge packs on site. I charge everything to 4.20 for right now because I'm going out running tomorrow. I'm sorry, 4.22. So tomorrow when I get out there, they'll probably drop and settle down to 4.20. You know what I mean? So they're ready to go. I'll usually test my cars with a full charge pack right then and there. I'll make sure steering, acceleration, everything is working correctly the way that car is set up to run. And then I will take the pack out and put it on the charger, top it off, and do the runs. And just keep doing that. You know what I mean? Take them out after the run, put them back on the charger, get them charged up. You constantly just working them. I believe that waking the batteries up like that improves the consistency of how the car is going to perform. So, you know, throwing in a cold pack or a pack that's out of storage, you know, might do the same exact thing. This is just my beliefs on that whole battery situation. I like to cycle. I guess not say cycle, but it's not cycling. I like to use the battery, charge it, use it, charge it, use it. You know what I mean? That's by like the second or third time. That's where I feel that now the battery is going to be at its most consistent with the cars. You know what I mean? It's going to behave consistently the rest of the day. So that's what I do. It works for me. I don't know if there's a difference from just throwing a cold pack in there. It might be the same data, but I personally like to do it that way. So that about sums up the what you want to bring out with you kind of thing. There's probably some other odds and ends that I'm missing because I haven't ran in about 2 months. So I'm pulling a couple things out of hibernation just to get this one day in. So there might be some stuff I'm missing, but you know, I'll throw it in another video or whatever. So yeah, that sums that up. Let's move on to the next thing. What was next? Okay, I got range booster install. I'm not going to do that today. We could talk about Perfect Pass and wasting watts. So I use Perfect Pass launch control on every car but 2. Now, the only reason I'm not using them on the other 2 is because they're test cars, and I like to do that myself. You know what I'm saying? Now, don't get me wrong. I'm not. If you're using launch control, dude, you are doing it still. It's. Let me explain this to you. Launch control is a much healthier way of running a car. It doesn't take nothing from the driver. It doesn't. What it's doing is making the car accelerate healthy. It's doing it perfectly linear. You know what I'm saying? To where some of us, I have bad nerves. You know what I mean? Like I'll keep it real with you. I'm a recovering addict. From years ago, I did, horrible drugs, and it damaged me. You know what I mean? It damaged my hands are so shaky now. My vision's not so good. Blah blah blah. So the launch control for me really smooths out my trigger pull. Now I've tested my trigger pull against the perfect pass. Dude, we're talking friggin', 2-3 miles an hour. I got it, boy. I still got it, but there's no point. I've got to that point, and now I just use the launch control because I know that this is the most healthiest way that the car is going to accelerate. And a trigger pull, you could be standing on your ladder and get a little shooken up about a bad foot placement and yank that trigger, and that yank at a certain level of these cars could be geared so high that yank right there is just going to kill your ESC, because you just sent a bunch of amps straight into the ESC because you yanked that trigger because you got scared or something. These are things that people don't really notice too much, and I'm just trying to inform you of it. So using launch control is the most healthiest way that you can run a top-notch car. It really is. You don't have to. You can absolutely do it by yourself with a trigger pull, blah, blah, blah. But I will tell you right now, you will not beat that amperage on a linear perfect pass pull. You can't do it. It's not physically, humanly possible. You can't do it. That control is so linear and so smooth that no hand can do it. It's perfectly linear as that. It's impossible. You prove me wrong, anybody. You know what I mean? That, for real, is the most healthiest way to accelerate a car, hands down. So I run them on my cars. I'm looking for peak performance, and once again, I'm going to use that. I'm looking for consistency. So me using that, I can set a certain amount of seconds, let's say 8 seconds, 10 seconds, 6 seconds. The duals can do it a little bit quicker because it's two motors working on one car. It's a lot more efficient. It's not as stressful. But I forget where I was going with that. What you can do with that now, this is cool. So when you got that launch control, and say you want to work on your throttle curve per se, right? You can go into the ESC and you see that little green square box, right? Well, that is going. I almost want to bring it up. That is your trigger pull. You see the line going through that box? Well, that's you pulling the trigger, right? So with the perfect pass, that line will move through in seconds, right? So you got your ramp in there, however you want to do it. From 0 to 100, that launch control is going to do it smoothly in whatever set amount of seconds. So if you know the distance of your road and you want to work on your throttle curve, you can use that launch control to literally pinpoint when that car is going to accelerate, when you feel that it's up to speed enough with that gearing to accelerate harder. It doesn't have to be perfectly linear. You know what I mean? These are some of the skills that you're going to learn and understand. Now, the perfect pass is a good tool for that, because now you are in control of when that car is going to accelerate perfectly in the throttle curve and everything. So say you have an excessive amount of gear, and you want the top end of that gear, but you can't have the acceleration of that gear. So either you can master the trigger pull of when to pull that trigger harder or lower or whatever. you could do it that way. It's much more difficult. It's a acquired skill. You will not get it off the bat, but for you guys starting, you can now use that perfect pass to do that for you, right? So I can set that perfect pass for 8 seconds, and in my throttle curve, I know that it's going to follow that curve in 8 seconds. So if I'm using an excessive amount of gear or whatever, or I'm trying to, get the top end of one gear, but it keeps cutting on me, I can then pull the trigger, let that car roll out slowly, because it's just you're following the throttle curve at that point. I can let that car roll out, and once I feel it's got an appropriate enough of speed to dump the energy, now I can put that in my throttle curve and ramp up hard, because that perfect pass is going to do it in an amount of seconds. You understand what I'm saying? It's hard to explain. I can visually show you probably better than I can explain it, but hopefully you guys get the gist of it. It is a crucial tool to learning your gearing and how to treat that gearing. You know what I'm saying? Because every motor, every pull is different. You're going to need to do it differently. So that's where working on your throttle curve, working on the distance that you have and what time you have to accelerate and what time you need to stop accelerating to use the brakes. I can stop my cars feet off of my runway and in a 3,000 foot pool. Ask anybody who's been running with me. They will tell you that I can stop that car right there at the end of that runway. I will use every foot of that runway. And the reason I can do that is because of the launch control, and I understand how to use it. You know what I mean? And I understand how to set my brakes to stop at a certain point and use that distance to stop. That's where you can use your brake curve, I guess. You know what I mean? But I don't do that. I just jam the brakes. So whatever percentage of brakes I'm set at, I know where I need to pull that trigger to stop the car and where it will stop. So these are like all tools that you guys can really use. And, you a lot of people just don't know how to use it, so that's why I'm here to explain to you. But, that might be it for this one. I got a couple other things we're going to talk about, but I'm going to save that for another video. I actually have to get back to getting this done so I can get out tomorrow. So hopefully this was informative. Thanks, guys. I'll see you on the next one. GoPro, stop recording.